Hi everyone, this is your math guru. In this video, I'm going to show you how to calculate the sum to infinity using the following sigma notations. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. The first question says, calculate the sum to infinity if the sigma notation of 2 in bracket 4 to the power of 1 minus r from r equals to 1 to infinity. And for the second question, the sigma notation of 4 to the power of 1 minus p from p equals to 1, that's the lower limit, to infinity. For the first part of the question, we need to determine the kind of sequence we have, and we can only do that by first of all determining at least the first 3 terms. So therefore, because a lower limit starts from r equals to 1, so we're going to put 1 wherever we find r. To find our first term, we have for t1, we have for t2, and t3. That will be putting 1 as our r. We have 2 in bracket, 4 to the power of 1 minus 1, that's for r equals to 1, plus for the next term, we have 2 in bracket, 4 to the power of 1 minus 2 for our second term. And for our third term, we have 2 in bracket 4 to the power of 1 minus 3. The sequence go on in that way. This is for r equals to 1. This is for r equals to 2. And this is for r equals to 3. Simplifying, we have 2 in bracket 4 to the power of 1 minus 1, that's 0, plus we have 2 in bracket 4 to the power of 1 minus 2, that will give us minus 1, plus 2 multiplying, I'm going to correct that. We have 2 outside the bracket, 4 to the power of 1 minus 3, that's minus 2. The sequence goes on. Any number or variable raised to the power of 0 is 1, so that will be 2 times 1, which is 2, plus we have 2, 4 to the power of minus 1 to make it a positive exponent. We're going to put it as a denominator, so we have 2 over 4, plus with the same thing, we're going to make our exponent positive, so we have 2 over 4 squared. The sequence goes on. If we simplify, we have 2 plus 1 over 2, simplifying our fraction, plus we have 2 over 4 squared is the same as 2 over 4 times 4, that's 16, that's 1 over 8 divided by 2, so we have plus 1 over 8. Therefore, our first term for the first question, which is a, is equal to 2, and to find a common ratio, we divide the term in front by the term behind. That's t2 over t1, and that must also be equal to t3 over t2. That will give us t2, that's 1 over 2, divided by t1, that's 2. We have 1 over 2 times 1 over 2, changing the division sign to multiplication. Then we flip our right hand side, therefore our common ratio is 1 over 4. A double confirmation will be a t3, that's 1 over 8, divided by our t2, 1 over 2. That will be 1 over 8 times 2 over 1, which is also equals to 2 over 8, and that will also give us 1 over 4 if we simplify. So we can see we have a common ratio of 1 over 4. Therefore, the sum to infinity, S infinity, is equal to a first term, a over 1 minus the common ratio. That will be a. We have 2 over 1 minus the common ratio, that's 1 over 4. That will be 2 divided by 3 over 4. 1 minus 1 over 4, that's 3 over 4. We have 2 times 4 over 3. So therefore, the sum to infinity of the first question will be 8 over 3. For the second question, we have to find the sum to infinity. We have summation or sigma notation, p equals to 1 to infinity of 8 times 4 to the power of 1 minus p. Like we did earlier, we need to find our first term, our second term, and our third term in order to find our first term and our common ratio. And to do that, we start with p equals to 1. So for our first term, we have p equals to 1. For our second term, we have p equals to 2. And our third term, we have p equals to 3. So if p equals to 1, we have 8 in bracket 4 to the power of 1 minus 1, plus our second term will be 8 times 4 to the power of 1 minus 2. We have 1 minus 2 plus 8 times 4 to the power of 1 minus 3, and so on. The sequence goes on to infinity. Therefore, simplifying, we have 8 times 4 to the power of 0 plus 8 times 4 to the power of minus 1 plus 8 times 4 to the power of minus 2, and so on. Any number or variable raised to the power of 0 is 1, so we have 8 as our first term plus 8 over 4 plus a third term, that's 8 over 4 squared, plus, if we simplify, we have 8 plus 8 divided by 4, that's 2, plus 8 over 4 squared, that's 16, 1 over 2, plus, it goes on. Therefore, with what we have, our first term, a, is equal to 8. And to find a common ratio is our t2 divided by t1, which is equal to a second term, 2, divided by our first term, 8, and that will give us 1 over 4. So going back to the formula for sum to infinity, that's a over 1 minus r, and that's equal to the first term, 8 over 1 minus the common ratio, 1 over 4. That will be 8 divided by 1 minus 1 over 4, that's 3 over 4. That's 8 times 4 over 3. Therefore, the sum to infinity will be equal to 8 times 4, 32 divided by 3. Thanks for watching. Bye.